Students, welcome back. Now we are going to see the vertebral column as a whole before starting the osteology of the thoracic vertebrae. Okay, so the vertebral column is also called as the spine or the spinal column. The vertebral column is also called as spine or spinal column or backbone. It is the central axis of the body. You can see here, this is the central axis of the body. It is the central axis of the body. It supports the body weight and transmit it into the ground through the lower limbs. So the head and neck weight is carried by this cervical and the upper limb thoracic and the thorax weight. So up to here the weight is transmitted to the lumbar region and sacrum. From the sacrum it is transmitted to the two lower limbs. So it supports the body weight and transmits it to the ground through the lower limbs. Okay. So vertebral column is also called the spine, the spinal column or backbone. It is the central axis of the body. It supports the body weight and transmits the body weight to the ground through the lower limbs. Okay, and this vertebral column is made up of 33 vertebrae, out of which 7 is cervical. So this is the cervical region, this green part, this is the cervical, 7 cervical and 12 thoracic, here also you can see 12 thoracic and 5 lumbar and 5 sacral, okay, 5 sacral and coccyx or 4. Coccygeal vertebrae is 4. So totally 33 vertebrae, 7 cervical, 12 thoracic, 5 lumbar, 5 sacral and 4 coccygeal. So these are the total 33 vertebrae present in the vertebral column. In the thoracic and the lumbar and the sacral regions, the number of vertebrae corresponds to the number of spinal nerves. That means we know that we are having 31 pairs of spinal nerves. So cervical vertebrae is 7, but spinal nerves are 8, isn't it? So you come to thoracic, 12 thoracic vertebrae and 12 spinal nerves, 5 lumbar vertebrae and 5 spinal nerves. Sacral also 5 vertebrae fused to form a single one. So 5 sacral spinal nerves and coccygeal we are having 4 vertebrae but only one pair of coccygeal nerve are present, isn't it? So that means here the number of vertebrae in the thoracic, lumbar and sacral region is equal to the number of spinal nerves. Okay, corresponding spinal nerves. So whereas in the cervical, so 7 cervical vertebrae but it is having 8 spinal nerves. And coccyx is having 4 coccygeal vertebrae though it is fused, so only a pair of coccygeal nerve are present. So that is the thing they have explained like that. So in the cervical region there are 8 nerves, the upper 7 lying above the vertebrae. That means we know that so spinal nerves are coming from the vertebral foramen, isn't it? Here you can see the vertebral foramens. So in the lumbar region you can see, so here, so some holes are present on the posterior aspect. So that is called as vertebral foramens. Through these foramens, the spinal nerves are coming out, isn't it? So, how they are traveling? So that means how they are running. So the upper seven cervical spinal nerves will move upwards. So they will run above the corresponding vertebrae. So, for example, so this is the third cervical vertebrae. The nerve is moving above the corresponding one. Okay, like this. So, upper seven cervical spinal nerves will run upwards, except C8 runs below the C7 vertebrae, below the C7 vertebrae. The remaining all will run above the corresponding vertebrae. Okay, and then in coccygeal region, in the coccygeal region there is only one coccygeal pair, a pair of coccygeal nerve. Sometimes these vertebrae are also grouped according to their mobility. According to their mobility. So the movable or true vertebrae, the movable or true vertebrae includes the cervical, thoracic, and the lumbar. So these are total 24 vertebrae which are having mobility. Okay, out of which 12 of them are attached to the ribs. 12 of them are attached to the ribs. The fixed and false vertebrae. Fixed and false vertebrae are sacrum and coccyx. And also, so what are the true vertebrae? So sometimes the classification of vertebrae based upon their mobility. So mobility of the vertebrae in the regions cervical, thoracic and lumbar region will have mobility, high mobility, and so they are called as true vertebrae, and the false vertebrae are the sacrum and the coccyx, sacrum and the coccyx. So these are false vertebrae. Based upon their mobility, such kind of classification has done. Okay, now the length of the spine. So the length of the spine is 28 inches in males and about 24 inches in females. Okay, out of which, so in between them you can see intervertebral discs are present. In between each vertebrae you'll have the intervertebral disc. So this intervertebral disc forms 1/5 length of the vertebral column. Okay, so total length is 28 inches in males and 24 inches in females, out of which 1/5 of the length is formed by the length of the discs. Okay, so as a result, many variations in the width of the vertebrae of the vertebral column has been changed, and sometimes they can be said to be in the form of pyramids. So for example, the upper cervical, so the width is from first to seventh, it is increased like this. So it forms one pyramid, and then up to C7 to T1, C7 and T1, and T4 to T5, the width is somewhat compensated here, and then again the width of the vertebrae is increasing towards the L5 and S1. So this one is another pyramid, and after that it forms the another pyramid from L5 to L5 and S1, from L5 to S1, another pyramid is formed up to the coccyx. So this is one kind of arrangement of vertebrae. Such kind of things is based upon the width of the vertebrae. So some of the variations in the width of the vertebrae of the vertebral column can be said to be made up of pyramids. Okay, so this arrangement has functional bearing. The narrowing of the vertebral column at the level of the disc between T4 and T5 is partly compensated by the transmission of weight to the lower thoracic region through the sternum and ribs. Through the sternum and ribs. So here the width is decreased. Here the width is decreased. Wherever the weight transmission of weight is increased, then the width of the vertebrae is also increasing. Okay, at this region what will happen? The weight is transmitted anteriorly to the sternum through the ribs. Okay, so here the entire weight is not present at this point. Here the weight is transmitted to the anteriorly and it is taken up by the sternum through the ribs. So such kind of arrangement you can see on the posterior aspect. So if you see the posterior aspect of the spine, it appears as in a straight line, but actually the vertebral column is not arranged in a straight line. If you see in the lateral aspect, you can see the curvatures. These are very, very important curvatures. So it is of having two kinds of curves. One is the primary curve and the secondary curve. Primary curve, actually when the infant is in the womb, the baby is in the flexed posture, so like this. So the entire vertebral column is also present in this manner. So this is called as primary curve. So this curve is called as kyphotic curve. What you call? Kyphotic curve. That means it is having anterior side. For example, lateral aspect we are seeing. So this becomes anterior, this is anterior and this is posterior. So such kind of curve is having anterior concavity is present. So anterior concavity is present in the curve, then it is a primary curve. So in the vertebral column, the primary curves we are observed or the one is the thoracic and another one is the sacral. If you see the thoracic curvature, you will have anterior concavity. Anterior concavity is seen. Whereas in the cervical and lumbar region, it is anterior convexity is present. So if any curve is having anterior convexity, then it is called as secondary curve. Okay. So primary curves are present at birth and are due to the shape of the vertebral bodies. The primary curves are thoracic and sacral, and both of which having anterior concavity. Whereas in the secondary curves are postural. So when a baby is born, then the curve is only a kyphotic curve, that is only primary curve. So when baby starts holding its neck, then the cervical curvature is formed. So this is the cervical curvature. It is taking place during the months of 4th to 9th months. Okay, and next curvature is developed. So that is the lumbar curvature is developed for the baby. Okay, lumbar curvature is developed for the baby at the level of during 12th to 18 months, when the baby starts standing in an upright posture. So then this lumbar curvature develops. So the curvature is developed due to posture. So then it is called as secondary curvatures. The cervical curvature appears during 4th to 9th months, and the kyphotic curve is maintained like that only, and the lumbar curvature is formed during the months of 12th to 18 months, when the infant starts standing in upright position posture, and then the sacral curve is maintained. So this is the these are the curvatures of the vertebral column. In this, the primary curvatures are the thoracic and sacral, and secondary curvatures are the cervical and lumbar. This is the secondary curvatures and this is the primary curvatures. So these are about a general information about the vertebral column. How many vertebrae are there, how they are formed, and what is the length of the spine, and what are the curvatures of the vertebral column, and also what are the motions taking place in the vertebral column, or flexion, extension, side flexion and rotation is taking place. So this such kind of movements are also varied region to region. In the case of cervical and lumbar, flexion and extension is having more mobility when compared to thoracic region. In the thoracic region, rotation is having rotation type of movement is taking place in the thoracic when compared to the lumbar and cervical, because in the cervical and lumbar the rotation movements are restricted when compared to the thoracic vertebrae. Because all these variations have been observed due to the orientation of the joints present in the vertebrae as well as the size of the intervertebral discs. This is about the general information about the vertebral column as a whole. So now we are very much worried about, now here is the thoracic vertebrae. So if you want to know the function of the thoracic vertebrae, you should know the structure of a typical vertebrae. So once you understood the structure of a typical vertebrae, so all the vertebrae in the vertebral column possesses same type of features, but there are some variations from region to region to identify whether it is cervical vertebrae, thoracic, lumbar, as well as the sacrum. So for that you should know the typical parts of a typical vertebrae. That thing we are going to see in the next video. Thank you.